Yeah, because imagine having your dad tied up for 3 hours. What's up? He told leave it plugged in the whole time. I can probably guarantee you, whoever told him that's not actually doing those types of inspections. Because can you imagine? You have to put it on the lift, plugged in. That has no logic. Whoever told him that. Yeah. Nah. Really? Because in reality, it's only going to be pulling any data once it actually starts the test. So, for me, it's do your whole inspection and then punch it in. Yeah, like it's like when you're doing an smog check, when you're doing your visual and then you punch it in, do the same thing. Perform all your tests, and then after that, punch it into the machine. Yeah. Yeah, because it's not like the machine's going to be like checking to see if you're actually doing it. All it's doing is it's going to query information from the modules and then go.
I know a lot of people that just have small troubles.
All right, guys, let's get rolling. So we're gonna do the full review today for the A4. I promised you guys some worksheets. It's a crazy ass day at the shop today, so I didn't get the chance to do them. But I am gonna finish them. I am gonna make them for you guys, and then I'll have them for you guys on Monday. So that way, Monday when we start breaks, you guys will be ready to roll. Cool. Tuesday. You guys, your Tuesday is my Monday, and then my Monday is Monday with another class. So, yeah. No, and then we finish breaks, and then we're gonna go into the inspection process. Yeah, the whole inspection process. Right. We're gonna finish off A5, and then after that, we'll go into the VSSI inspection. All right, so again, like we were talking about the other day, when we're taking the test, you guys are gonna have 12 questions. What steering system diagram repair, 12 questions on suspension system diagram repair, alignment, and then wheel and tire diagnosis, 5 questions. So it's gonna be, it's real simple. It's a basic test. It's not anything crazy. You guys already covered the A6, so there are gonna be some questions on electric steering. So again, DC motor, power, ground, it's going to make it spin. You guys already know that from A6. All right. Total of 40 questions. And I know you guys are going to do a good job. So, again, some of the fundamental steering components that the vehicle is going to be consisting of is going to be what? Steering column, steering box, steering linkage, and knuckle, depending on the actual design. So we're just going to do a quick review over some of the key points, and then we're going to dig into some of the other stuff that's a lot more important. So again, as we were talking about prior, depending on the vehicle, again, we're going to have our input, which is going to be our steering column, right? I want you guys to start thinking about it as inputs versus outputs, just like we do with sensors, inputs, and actuators. It's the same thing. Steering column is going to be your input, and then that input is going to be sent into your steering rack, right, in some instances, or a gearbox, depending on what application you have, right? Then from there, if it's a steering rack, the pinion gear is going to move the rack either right or left, and then that hydraulic pressure is going to help it move, right? So then that's going to give us a steering control that we need for the vehicle to either go right or left. And if I have a gearbox, it's going to be about the same thing. We have a steering column that's going to go down a shaft, usually to an intermediate shaft or like a little U-joint. Then from there, it's going to go to the gearbox. Then the gearbox is going to have a pitman arm. Pitman arm is going to help you do all the actual movement, right? So it's not too different from one another, but we need to be able to identify those two differences, right? So what we can see right here on the left-hand side, what is this one, a steering rack or a steering gear or gearbox? It's a gearbox, right? We got a pitman arm and an idler arm. Wouldn't that make it a gearbox? Okay. And again, right here on the right-hand side, we got a steering knuckle. What is a steering knuckle? What's the purpose of it? What does it do? It's going to hold your rotor in some instances. This one also has a hole for an axle. Did that hold an axle?
Yes.
Right? Is this going to be holding your brake caliper as well? And it's going to be attached to the vehicle using ball joints. Yeah. Sometimes it might be attached to a shock. It all depends on the actual design that you're going to be using, right? Okay. So over here on the left-hand side, what is this? That's your racking pinion. Would you guys agree that the pinion right there in the center is going to be your input to that rack? Okay, remember we talked about this when we were going through electrical, where I told you guys without an input, will a module be able to make an output control? No. So if your car is just there and you don't touch the steering wheel, is there any input for those wheels to turn? Hopefully not, right? Okay, so at that point, again, we're looking for that input from our pinion to then go along our rack to then turn it left or to turn it right. What we're looking over here on the right-hand side, this is an inner tie rod with the actual socket if you need to replace it. Okay, in some instances, it's actually just more labor conscious to just replace the rack. If you got to do inner tie rods and the car has over 100,000 miles, might as well just sell them a rack. Okay, that way you're putting in a whole new unit and you're going to alleviate other issues. Okay, and we've talked about this during classes, and I've always told you guys it's better to do the whole job so you don't have to do it again. Right? Okay. So again, you guys have to do that. It's better off to sell the whole thing. Tie rod ends, outer tie rod ends. If you guys are checking them, these boots are cracked. They got a lot of play in them. Are you going to recommend them as a set or individually? As a set. All right, cool. Are you going to go with the cheapest ones possible? Hopefully not. And how are you guys going to remove these? With a pickle fork or using a ball joint remover? Why? So what if I don't want to reuse this? Can I use a pickle fork? Yeah, because if I mess it up, it's all right. But if I'm going to reuse it, then I want to use a what? The tool, okay? The ball joint tool to pop it. Fucking have a brain fart, but I have a picture of it. I'll show it to you guys right here in a bit. Okay, but again, if you want to preserve it, make sure you use the right tooling. If you don't give a shit about it, use a pickle fork because you're going to damage the actual boot, right? Okay, so what suspension system is this? Parallelogram, right? On this one right here, is this going to be attached to a rack and pinion or to a steering gear? Steering gear. How do you guys know that? It's got a pitman arm, right? So we got a pitman arm on this one. That's going to be attached to the steering gear. And how does the steering gear get an input? From a steering wheel. Your steering wheel is going to input to the gear. The gear is connected to our pitman arm. Pitman arm is then connected to our center link, which is here, which goes over to an idler arm, which acts as a support for it. And then after that, what do we have? We have our inner rods with our tubes in the center and then our outer rods here, right? So that's the makeup of it, right? Again, when you guys are checking these and you guys are manually checking them, what's a good way of checking them for any damage? Just grab them and move them. You get a lot of play in them, a lot of popping in them that they got to get replaced, right? A lot of times what ends up happening is, and we see this a lot here in the shop, is a lot of guys out in the field and a lot of shops neglect to check stuff like this. So a car will come in for a service and that's all they're going to do to the car and then ship it, right? We've had cars that come in that been to perfect example. We just had a car that yesterday, Camry, that came in, had just gotten an oil change a couple months ago. And the shop who did the oil change only did the oil change. They didn't mention that it needed ball joints, that it needed control arms, nothing, right? So that's why suspension components begin to get neglected because shops don't bother to inform the customer about these types of issues, right? So this is why when a car comes in, not only for the inspection, but if for anything else, it's always a good idea for you guys to note all that, right? How expensive is it to do a full suspension overhaul on a car? And by that, I'm talking control arms, ball joints, outer tie rods, sway bar links, and struts. It's a lot. We just did one on a car. It was like over $2,500 in parts and labor. Right? So if you can slowly start pinpointing these failures, let your customer know about it. Can you save them some money? Absolutely. Right? Okay, what happens to the steering column during an accident? Collapses, right? Why does it collapse? One, so you don't get stuck, right? And then two, it prevents damage to your knees. Okay? So how are we going to be able to tell if the steering wheel's actually, or the steering column's been collapsed? Shorter. Okay. So if you guys notice something like that, then at that point you want to know that this vehicle's been in an accident. That steering column needs to be replaced.
In order for the steering column to be damaged, would it have to be a severe accident?
Yeah, it was probably a pretty fast head-on collision. Yeah. So one of those cars that looked like a soda can, and then they made it look all pretty with Bondo and shit. Yeah, one of those. What color are airbag connectors? Yellow. Okay. Can they be orange? Yes, they can. So when you guys are looking at the airbag connectors, one thing you want to pay attention to is when we take them apart, they're going to have a shorting bar in them. The reason why is because when you remove them, you don't want to accidentally discharge the airbag module. Okay. Also be very careful. Don't put anything in those connectors unless instructed to do so by service information, right? If you guys are removing a door panel, can those door panels have airbags? Yeah, right. So anytime you guys are going to be dealing with any repair near an airbag, make sure you disable the airbag so you don't accidentally deploy it, right? Not only are you going to have to then replace an airbag, but it can actually hurt you or even kill you if you're close enough to it, right? So be very, very careful with that. Also, when we're talking about airbags, you guys are going to see this on the ASE. If I need to disable an airbag, what's the best process to do so? Follow service information, right? Service information is going to be specific to that vehicle, but in general, wouldn't it be a good idea to disconnect the negative cable of the battery terminal? Why? If I do that, isn't it true that now I've opened the electrical circuit, so there's no the electricity that can flow through any circuit in the car, right? Okay, remember, in a car, battery or current flows from where to who, from who to who? Positive to negative. So if I remove the negative, there's going to be absolutely no current flow. True? Okay. So if I remove the negative, then at that point, would it be a good idea to maybe put some electrical tape around the actual battery cable or tag it like with the tags that we showed you guys? All right. This way, somebody just doesn't walk by and be like, oh, this is disconnected, and bam, plugs it back in and something happens with that airbag. Okay. The other thing you want to make sure you do is give yourself at least 10 minutes. And why would you want to give yourself 10 minutes before you start working on it? What do modules have? And they act as little batteries inside of computers. Capacitors. So a capacitor stores energy, right? And if I leave that computer idle for about 10 minutes with no current flow, it's going to discharge those capacitors. So the likelihood of it doing anything is going to be very, very slim, right? Okay. And then, is it a good idea to set an airbag down on a metallic surface? No, right? So make sure that you guys always set these down on something other than a metal surface. You don't want to accidentally discharge it. So make sure you put it on wood or something that's not conductive, okay? Also, when you set the airbag down, which way are you going to face the airbag module or the pad? Up, right? And if you're walking with the airbag, which way is the pad going? Away from you. So for some reason it deploys, it's not going to deploy to you, it's deploying away from you, right? And if it's on the bench, if it deploys up. right? Because if you put the pad down, if it deploys, that whole module is shooting up into the air, right? So be very, very cautious about that. And those are questions that you're going to see possibly on the ASE, right? That's messed up, huh? Sit down, bro. Guy sits down, boom. Just battery. Super easy. You guys can, if you go buy one at the junkyard, and you can do it at the shop. You guys don't have anything to do.
Kill your friend while you're
Yeah. Kill your coworkers while you're chilling, right? Okay, so what we're looking at right here, this is a standard rack and pinion. Again, remember your input's going to be your steering column. Inside of the actual rack, we got a rotary valve. This valve, based off of your steering column position, is going to allow fluid flow in one direction and then return in the opposite. So this is what's going to give you the hydraulic pressure to go one way to allow it to move, right, in whatever direction or input that you're inputting into the hydraulic rack, right? Now, this one right here, this is a warm gear gearbox. So again, we got our warm wheel here, and then we have the gear situated right here. Okay, so it's acting like a screw. So as it spins, it's going to then rotate and then move it over one way or the other. Okay. So on these right here, again, on the top one, we have a, what is this? This is a gearbox. And then on the bottom, again, we have a diagram of a rack and pinion. So a worm gear absorbs significantly more road shock compared to a rack and pinion system, reducing the amount of transfer to the actual driver. Which system are you going to feel the most when you're driving? Rack and pinion or a gearbox? Rack and pinion. So a vehicle with a rack and pinion, as you're driving down the road, you're going to be able to feel more of the road on your actual steering, right? Where versus when you're driving like a truck that has a gearbox, you're going to feel less of it because of the design of the actual steering. Okay. So remember, we have three different types of power steering systems. We have a full hydraulic, then we have electronically powered hydraulic system, and then we have a full electronic system, right? So most manufacturers are going away from full hydraulic because what does that power steering pump consume? Horsepower, right? So as a power steering pump's actually turning, it's using up horsepower. In order for us to produce more of that horsepower, it uses more fuel, right? So in order for manufacturers to conserve fuel, what they're doing is they're moving away from belt-driven hydraulic pumps to electronic hydraulic or full electric racks. Okay, so utilizing pressurized hydraulic fluid to aid the driver in maneuvering the wheels. When the engine is running, fluid circulates constantly from the power steering pump to the steering gear. Control valve then returns back to the pump. What were to happen if you guys are looking inside of the fluid reservoir that's by the power steering pump and you don't see any fluid coming back? It could be the filter that's plugged up, right? What else could it be? Could it be the pump itself? Possibly, right? Or could it be the rack? Might be the rack. What if you don't have any power assist? You're trying to turn the wheel, and the wheel's super freaking hard. And as you're doing so, you're not seeing any fluid shoot back into the actual reservoir. Right? Could that be a bad rack and pinion or a rotary valve inside the rack? Yeah.
The rotary valve, the one that directs the fluid.
The one that directs the fluid, right? Then you come to find out, a customer tells you, oh, the vehicle was in an accident previously. More than likely, it's going to be who? The rack. Okay? So while the steering wheel remains centered, only a small amount of pressure is required to keep the fluid moving, minimizing the engine power needed to operate. Right? You guys remember the old Fords? We used to turn the wheels like right, to the other side. The old school systems. So again, the rotary valve is positioned in the steering wheel input shaft and it regulates hydraulic pressure. Turning the steering wheel causes the rotary valve to change fluid direction, either one side of the piston connected to the steering gear. For rack and pinion steering systems, the piston is integrated to the center of the steering rack, while the rack housing functions as a working cylinder. Okay, so again, the housing of the rack is going to maintain that pressure, so it's going to be able to direct it either way. And then as you move your input, right, which is your steering wheel, then that rotary valve is going to move, moving the flow of fluid in one direction or the other, right? Again, it's all based off of what? Input, right? So this right here was just a standard power steering pump. If you got a vehicle that is, let's say, for example, a diesel, right? How do we run the braking system or the hydraulic brake assist on the diesel? Power steering pump, right? So if you guys ever have a car that you don't have hydraulic power assist and you have no hydraulic braking, what more than likely failed? Power steering pump. Okay. I remember back in the old days, you guys know what an Astrovan is? All right. So I had an Astrovan I got to work on once. Customers' complaint was that no power steering and no braking. You turn it on, you see the power steering pump moving and everything. You open the reservoir, but there was no movement of fluid in the reservoir. It's like, huh, it's interesting, right? So sold the power steering pump. When I take the belt off, the pulley falls off. The shaft broke, right? So I was like, oh, cool. There's a fix, right? It needs a power steering pump anyway. But that's one key thing of remembering is if you lose both, right? On a hydro boost system, which uses a power steering pump to run the brake booster and the power steering, then more than likely you got a power steering pump that took a dump. Okay. This is a good one. Have any of you guys ever ran into this type of situation where customer complains of the car dying when they turn the steering wheel? Hey, I've had it happen once. Ford Focus. Okay. You turn the wheel, car would die. Huh. Interesting. Right? The way that I saw that was this power steering pressure switch right here. So this switch, you have a data pid for that. If you plug in your scan tool, you can watch the data pid for it. Turn the wheel, you're going to see the switch position change. Right? On that Focus, when I would turn the wheel and it would die, the switch would stay in the same position. So the computer didn't see a switch position change. Is it going to raise the RPM to overcome the stress and load of that turn? No. Computer thought you were still going straight, right? Now, computers are smarter, cars are smarter. Not only is it going to look at that, what else is it going to look at? Don't we have steering angle sensors? So the computer also knows what position the steering wheel's in. So if it sees that there's movement in the steering angle, but there is no movement or no pressure change here, will the computer possibly raise the RPM? Yeah. And then maybe it'll set a code because then it's like, wait, this is not plausible. How is it that the wheel changed, pressure didn't change, so then I had to increase the RPM, right? Or you might have a customer that's complaining about the car that's just erratically raising the RPM. Because what if you have a faulty steering angle sensor that's giving an input to the module saying that the wheel's moving, but in reality it's not? Okay. So this is why, again, I want you guys to get used to inputs versus outputs, right? If you got a bad input, you can have a bad output. But a lot of times techs just skip the basics on the inputs and go straight to the outputs, right? Okay. What do you guys know about electronic power steering racks? Besides they're expensive. So what two things do you guys need for a DC motor to work? Power and ground. So if I got a car that has an electronic power steering rack, when I do an input, right, is there going to be an input sensor such as a steering angle or a torque sensor going to a module, then the module sending out a command to an electric motor to either spin it one way or the other to give you steering? Yeah. Okay. Is that similar to like how a fuel pump works? Yeah. Right? So remember, it's a DC motor. It needs power and ground. If it doesn't have an input, there's no way that output is going to work, right? So the major difference between our hydraulic system and this is this one needs inputs. So if you ever get a car that comes into the shop where you got an electric power steering rack and you're trying to diagnose it, a scan tool is going to be your best friend here. because all we got to do is plug in the scan tool, look at my inputs, and if my inputs are there, but I'm not getting an output, then I need to see if the computer's sending that output to that motor. If it is sending the output, what's the outcome? It's a steering rack. Does that make sense? Okay. Now, I know we talked about this before, but if you guys replace an electronic steering rack, do yourself a favor, put a new one in it. Unless you guys got cloning software where you can clone modules, but other than that, you want to put a new one in it. Because a lot of times these modules are global A modules. You can't reprogram them once they're programmed once. Okay? So don't end up in that problem where you install a used one and then you find out later like, shit it's not going to work, right? You already quoted it to the customer, and then all of a sudden now you're down $1,000 because now you got to put a new one in it. Okay?
Doing it for free.
Now you're doing it for free. You're doing it as a hobby. So electronic power steering on this one right here, this is electronically, electronically assisted steering. We got a motor here on the assembly. It's got a torque sensor. Steering input goes here. Torque sensor sends information. That motor assembly then spins the shaft, which then spins our steering gear, right? So this is another option that we have. With electronic power steering. Okay, so just like we were saying, we have column assist, pinion assist, rack assist, and direct power steering type. Okay, so when we're talking about electronic power steering, or EPS, we're going to have a torque sensor. This translates the steering torque input and direction into a voltage signal, allowing the ECU to track them. Right, so this input is going to be super important for the actual module to then know that it needs to carry out an output, right? Okay, I keep telling you guys, it's all about inputs and outputs. Our rotation sensor, it converts both rotational speed and direction into a voltage signal for ECU monitoring. So again, the torque sensor is going to be letting the PCM know as an input, and then the rotation is going to verify it. Right, so it's going to need both. If you lose one of those, might it still work? Yeah. Okay, because it'll be redundant. Would you get a code for it though? More than likely. Okay. We don't want to lose full steering ability, so it's not going to lock up. It's just going to be hard as shit to actually turn. Okay, so. Right? Okay, when we're talking about tools, Pitman arm mover, what do we use this tool for? Pitman arm, right? Take a Pitman arm off. What about a tie rod end puller? When are you going to use that? Right? What if you don't care about damaging it? Can you use a tool or can you use a pickle fork? Cool. What's this right here? Pickle fork. So if you want to damage it, don't care for it, you can use that, get rid of it, right? Okay. How are we going to diagnose most of the components on the suspension? Physically check it, right? Get underneath it, rack it, and then check it. All right. Get in there, take some pictures, all that fun stuff. So this way you guys have a good idea of what's going on with that suspension. So let's break that down. Worn rack and pinion or steering gearbox. What are some of the symptoms? Can we have stiff, inconsistent powering effort, making it hard to turn in one direction or requiring noticeably different effort between left and right turns? Unusual noises such as whining when turning the wheel, and visible fluid leakage around the steering gear or rack, right? Those are some of the common things we might be able to see. So how do we identify it? We can do a visual inspection. While the vehicle is stationary, turn the wheel to detect any noise or resistance. Full left, full right. When the vehicle is stationary, let's see, inspect the power steering fluid level. See if it's low. See if you have any metal shavings, right? And perform a pressure systems check. What are some of the things your client might be concerned about?
Hard steering.
Hard steering. Okay.
Vacuum pinion or gearbox.
Rack and pinion or gearbox. All right. Inner tie rod ends. Noticeable play or clunking sound when turning the steering wheel. Uneven tire wear affected in the inner tread. Why the inner tread? I'm talking about the inner tie rod, right? Okay. So you're going to have a lot of play on the inside of it, not at the actual knuckle. Steering wheel vibration, right? And shimmy, especially at high speeds. And how do we identify that? You want to check the inner tie rod for any signs of looseness or wear. Use a pry bar to test the movement, observing how the inner tie rod reacts when the steering wheel is turned. Perform a hand-on test by gripping the tie rod and moving it inside, side to side to detect any excessive play. So again, your client might be concerned, might be uneven tire wear for potential alignment issue, steering instability, and of course safety, because if that shit breaks while you're driving, good luck, right? Okay. Outer tie rods, clunking, knocking sound when turning, uneven tire wear, and loose steering feel or pulling to one side. A car is going to pull to one side if it's which alignment adjustment is off.
Camber.
Is it camber? And caster, right? Okay. And if it's camber, is it positive or negative? Positive. And if it's caster, the negative. Okay. So right here again, how to identify and perform visual inspection for signs of damage and wear of any tie rod end. With the vehicle lifted, move the wheel side to side. Any noticeable movement suggests a problem. Use a pry bar to check for excessive play at the connection points of the actual tie rod. Customer is going to be excessive tire wear and complains about poor handling and unstable steering performance. All right, so some of the things that you guys can pay attention to, especially if you're taking a test and the test tells you about any of those options, then you can start thinking about that, right? Okay, next one is going to be power steering pump. Some of the symptoms you might have: whining noise, increased difficulty in steering, particularly when the vehicle is stationary, low power steering fluid without any obvious external leaks. How do we identify that? Inspect the power steering fluid for contamination or burnt odor. Check the pump for leaks and listen for unusual noise. Use a pressure gauge to test the system and visually examine hoses for cracks, leaks, and signs of wear. I've seen hoses that are so damaged when you turn the wheel, you see the hose start to flex, right? When that's happening, you're taking away from the actual hydraulic pressure going into the system by moving the hose. So the pressure you're going to use to steer, the hose is using it to move. Okay, so that's why it's a good idea to do a visual inspection on that. All right, and that's usually just deterioration of the hose, so the hose needs to get replaced. Once you do that, then that takes care of all that. It looks like a fucking snake. Okay. Struggles with steering, particularly at low speeds, and annoying whining sound when turning. Right. The ones that always come to my mind are the old Fords when it's doing right, and you put a new pump in, it should still sound the same. I have no idea. What I can tell you is I remember an old timer saying, I don't know if this is true, that they used to put fabric softener in some of them and they would shut up. I never tried it though. It was more of like, that's you do you, but they say that if you put fabric softener in there with some ATF or power steering fluid, it just shuts up. Yeah. In reality, if your car is whining like that and you got a newer car, oh yeah, you got an old Ford, huh? Yeah. Just now you got some homework. All right, steering column issues, stiffness or binding. What would happen? Customers complaining about like every time they're turning, it kind of binds, sticks up. Could that be a clock spring issue? Yeah, right. If you have a steering column, most of the time steering column also has a U-joint. That U-joint could get damaged, so you can get a lot of play and clicking out of it, right? I used to own a Dodge 3500, and when it was brand new, it was cool. about 40,000 miles in, I started feeling clicking and looseness on the wheel. So then went underneath and you could grab from the U-joint and you would get a good amount of play from the joint. So you would grab one side, grab the other, and move them, and you could see them move. And it's like, all right, cool. Well, I need to replace the little intermediate shaft, and that take care of the problem, right? So that's why the visual process is super important. Unusual noises from the column, such as clicking or popping, inconsistent steering effort while driving. Examine the steering column for visual damage. Check for any loose components. Turn the wheel lock to lock. And then inspect the clock spring and airbag components if possible, right? If you guys need to do a clock spring, make sure that you guys mark it, remove it correctly, and reassemble it in the same position, right? Okay, if we have a leak, what are we going to be using to find that leak? Dye, right? I love this shit. We used it today to diagnose a leaking transmission. Okay, we put that in there, you run it for a little bit, and then afterwards you take your UV flashlight, put on your goggles, you'll see it right away where it's at. We snap a picture, we put the goggles in front of our camera, we snap a picture, and then we show it to the customer, like, this is where it's leaking from, this is what we got to do to fix it, right? It takes the guesswork out of finding leaks by using UV dye. Best part about this UV dye, it works engines, transmissions, and power steering. They also make one for cooling systems. We use it when we can't find the fucking leak. We just used it on a, 19 Pacifica, because it would drop pressure, but we couldn't find where it was leaking. Because typically you'll find a puddle. There was no puddles. There was no puddles. There was no signs of an actual leak until we ran dye in it, and then that's when we found that it was from the heater core hoses where it was actually leaking from, right? So dye, if you guys are not using dye to pinpoint leaks, you're missing out. That's the part number for it, $384. AutoZone carries it for $28.99. Anytime we run this test on a car, we charge $7 per every ounce of that fluid. It costs you money, you got to charge for it, right? So if we add dye, it's $7 per ounce. So we just fill up that little thing right here. That's 1 ounce. Pour that into the car and then run it. Okay. All right. What about these bad boys? What do these do? Power steering filters, right? If one of these is restricted, what kind of problems can you have? So we can have a whining noise coming from the power steering pump, particularly noticeable when making low-speed turns. Why low-speed turns? Do we have more or less stress on the steering system? More, right? Because you got the full weight of it. Usually when you're going higher speed, technically it's going to be a lot lighter when you actually make that turn. Decreased steering assistance, so it's going to be harder to make that turn, right? It's going to be a lot stiffer. And then power steering fluid leaks caused by excessive pressure buildup in the actual system. Is it a good idea to replace these if you guys are servicing the system? Yeah. Okay. You guys are charging for it, right? You're gonna have a problem selling it.
Almost all the cars that have all the cars.
Not all of them. Some of them do. Some don't. You got to look them up. Yeah.
Okay.
So when you order your parts, you can see if it has it. We found one the other day. We found a universal one that you can add, but if it doesn't have one, then you can just leave without it. Yeah. All right. So suspension principles. Let's talk real quick about suspension. What do we need suspension for? Did you guys agree? Stability, right? Ride. We want to have a nice, smooth ride, good operation, and we don't want to get off the car and have a headache from bouncing around inside the car, right? So when we're looking at the suspension, right, this is how it typically functions. We got our normal one over here on the left. Suspension right here is at normal ride height. In the center, we're having a compression of that actual suspension as the vehicle's tire goes over a bump. Notice how the spring becomes compressed, and so does the actual strut right here. On the right-hand side, we got our rebound, where now the strut and spring are opening to then push it back down to make contact with the actual ground. Okay. Would you guys agree that if we have a spring that is weak, can that affect alignment? What is it going to affect? Which one? Camber, right? Okay. You guys remember I was talking to you guys about if you guys do struts, it's better to do loaded struts. Why? Think about it. You're doing struts on a car, right? Give you an example. Car has 125,000 miles. And you're changing the struts on it. How many miles do those springs have? Same amount. Okay. There's a high probability that spring has already lost tension. Right? Springs lose tension over time. So why not do a loaded strut with a new spring so this way you can overcome that problem instead of having to do it again? Does it cost more? Yeah, it does. But in the long run, it's actually cheaper for the client and also cheaper for them in both ways. One, because it's not going to affect alignment. And then two, they don't have to pay you to disassemble it. All you're doing is removing and installing a new one. Right? There's a difference. Okay. If you guys look up service in your service manual for labor guides, your labor guide usually has remove and replace, and then it has remove, replace, and overhaul. Okay. And those are two different labor times. So again, those are things that you want to pay attention to when you guys are writing them up. So when we're dealing with the vehicle, right, we have driving thrust, which is a force that moves the tire's contact patch through the axle housing. We have braking torque, which applies a twisting force to the axle housing in the opposite direction of rotation when braking, and cornering force causes lateral movement of the axle housing while turning, right? You guys remember these? X-axis, which one is it? Is it yaw, pitch, or roll? That's going to be roll, right? Okay. And then your y-axis is right over here, which is your pitch. And then yaw is going to be in the center. Okay. So suspension components. Let's talk about different types of suspension. What kind of suspension is this one that we're looking at in the picture? LR something?
What was it? The lower long arm.
Isn't it SLA?
SLA.
Short long arm suspension, right? Okay. So that's important for us to know the different designs based off of the suspension that we're actually dealing with, right? Especially for us here in California, if we're going to be doing vehicle safety inspections, are they asking us what type of suspension the vehicle has? Yeah. So we need to understand which one we're looking at. Does that make sense? Okay. What if you enter it wrong? What's the state going to say? Like, damn, that's crazy. I could have sworn that car came with a strut, not upper and lower control arms. See, they swapped it, right? They modified it. They chopped it up. Okay. With a 5-lug on one side. I'll never forget that car. It was green. I thought they were messing with me, to be honest. But no, it was 3 tires had 4 lugs, and the fourth one had 5. All right, so when we're talking about suspension components, we got a spring. Spring is going to help us absorb a lot of the impact and support the vehicle weight. Our axle is going to be responsible for driving and supporting the wheels. Our shock absorber is going to help us also absorb some of that impact and help us channel it away. Our control arms are going to be load carrying, right? Our rods are going to help us get a better, a sturdier suspension. And then our ball joints are going to be our swivel connectors that are fixed to the outer ends of those actual control arms, okay? But again, most importantly here, what you guys want to remember is what type of suspension is this? SLA, right? Okay, when we're looking at our springs, what would happen if you start seeing springs with open gaps like you see here? Is that a problem? Yeah, that's terrible, right? You see that, you better be selling springs or talking to your customer about getting some new springs, okay? You know how some people grab a torch, heat the shit out of them to make them shorter, okay? How's a car going to ride? Right? Aesthetically, it looks nice, but is it really going to ride well? No. Right? Have you ever put coilovers on a car or ever test drove a car with coilovers? How do they ride?
On stick. And everybody probably buys the cheapest ones.
The ones they found on eBay or Temu? All right, leaf springs. Where do we use leaf springs at? Mostly in the rear. Are there some vehicles that have them in the front? Yeah, you'll find some trucks that have them in the front. Okay, when we're looking at leaf springs, we got leaf spring hangers, and we also have these shackles. Some of these shackles can help us either move the spring down more or up more, right? What would happen if, let's say this is on the rear axle, and you have this center bolt that breaks, or one of the clips that break, so then now, or the U-bolt that holds the leaf spring to the axle breaks, and the axle shifts. What's going to happen to the car? It's going to run like a crab, right? What is that called? Starts with a T. Yeah, the center line. Thrust angle. Okay, so if we have an issue with that, then is that going to affect our thrust angle? Yeah. Okay, so always remember your thrust angle is going to be that measurement that's going straight down the middle of the car, right? And it's going to line up with that rear axle. So if that rear axle is out of alignment, how is that going to affect the vehicle's angle going down the road? It's going to be off, right? Okay, so you're going to get a question on ASE about thrust angle. Okay, so always remember thrust angle is basically forming a T from the rear def or rear axle to the center line of the vehicle. Okay, if it's off in any way, shape, or form, the car is going to be what? Crabbing, right? It's going to rock like a crab sideways, or like a drunken sailor.
Video just thrust angle.
You got to find what component's damaged and fix it.
Well, like measuring the from where, from the frame to the
From the front wheel to the rear wheel, the setback. Okay, torsion bars. If you guys are working on a car with torsion bars and you guys need to remove them, mark them. So this way you make sure you put the torsion bar back in the position you took it off from, right? Nothing worse than you mix them up for some weird reason, and then you got a car that's running all lopsided or single-sided, anything like that. So if you guys are working with anything with the torsion bar, when you remove them, mark them. So this way you put them back in that same position, okay? What the torsion bar does is it carries the weight of the vehicle with rotating bars around a core to generate the spring effect. The stiffness of the spring is determined by both the torsion bar's length and its thickness, right? What do sway bars do? What do they help you support? Help stabilize the vehicle during turns, right? Okay. What kind of issues would you think of or hear about from a customer standpoint if you had a problem with a sway bar end link? Maybe too much roll, right, as you're going through a turn. What else? What about like a clicking or popping? Right? Okay. And then would you guys agree that this sway bar also has bushings? What happens to bushings when they dry out? Okay. They start squeaking. Okay. So that's another thing you want to pay attention to, right? So as I told you guys in class, sway bar, chassis ears are going to be your best friend when it comes to pinpointing these noises, right? Or what do we use in class? The scope with the noise sensors. Okay, either way, it doesn't matter what you use a stethoscope, you have somebody driving and you're hanging on by one arm and you're hanging out the car to hear it, whatever you got to do to find the noise, right? But as safe as possible would probably be the best bet. This is why we use chassis ears. It's much easier. Okay, when we're talking about a shock, what's one of the ways you know if the shock's bad? Leaks. If you see any, excuse me, you see any moisture or seepage right here at the top, would you guys indicate that that's a leaking shock or strut? What else can you do for it? Can you do a bounce test? Right? If I push down on the car and the car just keeps on bouncing up and down, what does that mean? Probably bad, right? Okay. Are you going to replace one or both? Both, hopefully. Right? Don't do one, do both. Do it in a set. And don't cheap out when it comes to shocks, struts. Get good stuff whenever possible, right? Okay, what kind of suspension is this? McPherson, right? This strut system uses a upper section of a hydraulic strut, serves as support for the actual vehicle and connects to the actual steering knuckle. So we got a lower control arm here. We got our wheel assembly or steering knuckle here, which then attaches to our strut with a strut top mount here and a bearing, right? Okay, all of that gets assembled into the vehicle. So now instead of holding the weight of the vehicle on the lower side, right? Because remember what on the short long arm suspension, where's the shock at and the spring? It's on the bottom. So we're supporting all the weight at the bottom of the vehicle versus here, excuse me, the strut is at a higher center point, so we're holding it higher up, right? This is why most manufacturers are going to this style because it's better for the vehicle. It gives you a better ride, okay? What about vehicles that have automatic adjustable shocks? How do those work? We got a leveling sensor, right? What is a leveling sensor? Right? It senses level of some sort, but how does it do it? What's a throttle position sensor? What is it called besides a TPS? What's the standard name for it? It's a potentiometer, isn't it? Variable resistor. Okay. So if I have a level sensor, would you guys agree that that's a potentiometer? Based off of position, it's going to give a voltage back to a module and let a module know if that position is too low or too high, right? If it's too low, what is the module going to command? Airflow. It's going to send air to it, right? Then if it's a air strut, it's going to inflate and it's going to raise it. And once that sensor senses the right position, reports it back to the module turns it off. Is there such a thing where it overpressurizes and raises it too much? Yeah, so then it's going to relieve some of that pressure. Okay. I gave you guys an example when we were talking about in class, like the old Lincoln Town Cars, the old Crown Vics, the old Expeditions and Navigators used to have airbags. And you had to disable them before you put it on the lift. If not, you were going to find out real quick that you didn't turn it off. The moment those tires left the ground and the suspension started hanging, you'd hear that air compressor kick on in the front. And then you just start hearing all the clicking and everything going on because now you're inflating that airbag because it's trying to level the suspension, right? So then it's like, oh shit. At that point, you hit the lift, bring it back down to the ground. So that way you can go underneath and turn it off, okay? So that's something that we need to pay attention here. So this right here is our basic control arm. We have on this, the one over here on the left, we got two of them, right? We got the upper and lower, the small ones at the top, the long ones at the bottom. Two ball joints hold the steering knuckle together with a shock and spring, right? Most of the time, if you guys are replacing a control arm, make sure that you're doing it with the new ball joint. So this way you're giving the customer the best ride, right? Don't keep an old ball joint on a new control arm. That doesn't make any fucking sense, right? And what are these? This right here. That's a strut rod. And you guys ever owned like a mid-90s Ford Explorer? They used to use these a lot. Ford used to use this a lot. Back in those days, if you had like a Ford Explorer, like a Ford Sport Track or something like that, or Ford Ranger, and those strut rods, if that bushing went out, when you would stop, you would feel like the whole truck or the cab kept going, but your suspension stayed back. Okay, what the strut rod's going to do is it's going to help you keep that suspension level or straight whenever you're putting a lot of stress on it by stopping, right? So one of the ways we would do it, rack it, and then we would check the actual bushing, and we had a lot of play, and then we would sell the bushings for the actual rod. When you're looking at ball joints, which one is the loaded ball joint in this diagram? The bottom one or the top one? Why the bottom one? Because it's holding weight, right? The bottom one is holding a lot of the weight. Which is unloaded? The top one. Okay, good shit. Now, if you guys needed to replace these, what are you going to use to open it up? You're going to replace the ball joints. You could probably use a ball joint tool, or if we're going to take them off or replace them, pick a fork, right? And an air hammer. Okay. Yeah.
Should come off really quick.
Oh, hell yeah. But if you use a air hammer, what else are you using? Hearing protection. You guys ever used an air hammer in the shop before? She's loud. And if you're around an air hammer and it doesn't hurt your hearing, doesn't mean you're used to it. That means your hearing's fucked up. Okay, I can attest to that. I've had my hearing checked and I'm borderline hearing loss, and that's due to pneumatic air tools. So make sure you guys use hearing protection. Okay, what are we looking at here? So the ball joint on the left, is that good? What about the one on the right? No. Okay, so this one right here, this is a ball joint with a wear indicator. As you guys can notice, that little your grease fitting. Careful, Ricky. Your grease fitting is still popping out, so that's in good shape. On the one on the right, grease fitting's been pushed in, so that's showing you that that ball joint has excessive wear and needs to be replaced. If you guys are doing a safety inspection and you notice that that ball joint on the right is on a card, does that pass or fail? Fail. You're gonna sell them a ball joint. Okay. When you see stuff like this, one of the best things, if you guys are already in the shop, it's always to be using a good service software, a shop management system that lets you take pictures. Because you show that to a client, they're going to see why you're recommending it, right? Versus you just telling them, now you can actually prove why it needs it, right? When we're looking at bushings, make sure you guys are checking them. If you start seeing that they're cracked, super flat, that means they need to go and you need to replace them, right? What's one of the common signs you're going to hear with bad bushings? Squeaking. So when we're looking at a bushing, like something like this, why does a bushing squeak? You guys ever asked that question before? So usually the rubber compound, that's the bushing, breaks away from the outer shell. So what you're hearing, the squeaking sound you're hearing is the rubber actually moving in and out, or not in and out, but around. Okay. So that's why if you're driving down the road and you hear a BMW pass you up and it's like going down the road, it needs control arm bushings, right? So that means that the bushing again broke away from its housing, so it's moving, and as it rubs, it squeaks. Okay, so that's what you're actually hearing, right?
What about, like, I've seen on another test that to tie in the lower control arms, or like the bushings, it has to be on the ground.
Mm-hmm.
Is that going to be on this test?
No. One on the left, is that a dead axle or a live axle? What's the difference between a dead axle and a live one? So a dead axle doesn't have a differential, right? The one on the right has a def. So this one's a live axle because it's actually going to be doing some work. The dead axle is basically just holding the spindle for the wheels. Okay, that's about it. Okay, so that's the major difference between the two components. Okay, so the one on the left, we got a solid axle, and what about on the right? It's independent, right? Which one's going to give you better stability going down the road? Independent. Okay, so when we're talking about McPherson strut assembly, what are you looking for that setup? Complete strut, and what else? Well, we have a lower control arm and a knuckle. Yeah, right? Okay. What about this one? What is this? That's a McPherson here, but which one's this one? Isn't that a modified strut? So this one's a modified strut suspension, right? Because we have our strut here, but where's your spring? Part. Aside from it, okay? So this one lacks an integrated spring within the assembly, and it's found on the front in certain vehicles and on the rear on others. Utilizes a single control arm with a strut position similar to a McPherson strut assembly.
me, that just looks like the rear of the cars.
Yeah, some. Who uses this?
Maybe.
Chevy? Who else? Who uses this strut? This strut type? When was the last time one of you guys worked on a Honda? Never. Isn't this like a Honda? It is, right? Okay, so Honda uses this style. A lot of manufacturers are using this now. Ford uses this. So this one right here is a double wishbone modified strut. Okay, so again, it just depends on who the manufacturer is and how they're actually utilizing it. So what you have here is you actually have a upper control arm at the top, and then you're going to have this longer spindle that comes here, and then you're going to have the wishbone type here at the bottom for the strut, usually with a drive axle that goes right through the middle of it. Okay, I remember seeing these in the early 90s on Hondas. I got to work on those Hondas towards, the early 2000s. So they've been around, right? So that's that system is been around for a while, and it's still around today. So you guys need to be able to differentiate those two types. Right? Yeah. I'm asking ChatGPT. Which suspension is this? SLA. So this is a short, long arm suspension. Where's the short one go? Top. Long one? Bottom. Okay. And what holds them together? Steering knuckle. Okay. And then where's your loaded ball joint? The bottom. Unloaded? Top. Okay. Who uses this? Ford, right? Twin I-beam suspension. Okay, this is a independent suspension system that's used with I-beams, right? This was, I mean, shit, I remember seeing these up into the mid 2000s. Don't know if it's still around. I haven't seen one lately, but this was around for a cool minute. Okay, I would see it a lot on the Fords, right? The old square bodies, the old 250s and stuff like that. You would see it a lot, right? Okay, what have you got suspension with airbags in the rear? How does this work? You guys told me a little while ago. It's going to have a leveling sensor. This one actually has a leveling valve. Is that going to work like a sensor? It's like a proportioning valve in a way, right? So here, as the valve based off of position, if the airbag starts losing pressure, suspension's gonna, or the vehicle's gonna drop, which is gonna open the valve and then allow airflow into the airbag, which is then gonna expand it and raise the vehicle, right? Okay, so this one's more of a mechanical style leveling system versus an electronic with some sort of sensor input. Okay. So the height sensor operates using the induction principle to continuously measure the gap between the vehicle's axle and the chassis. If the right height drops too low, the control system directs air to the necessary adaptive shock absorber. Adjustments to air pressure can be made based off of factors such as vehicle speed, driver selected modes, and automatic modifications determined by the control system. So what if you got a vehicle, right, that has a air suspension system, but the vehicle also has selective modes like sport mode, stuff like that. If you put the vehicle in sport mode, sometimes these manufacturers will actually lower the suspension to give you better control. Okay, so they'll actually relieve pressure from the bag, so this way the vehicle will come back down, right? And then once you put it back into like economy, it'll raise it back up, right? So you see that on some of the European vehicles, you'll see stuff like that if it has an air strut. Huh? You don't want one. All right, so what are some suspension faults? Let's talk about them. Ball joint. What kind of problems would you see? Clunky noise. So ball joints often produce a clunking or knocking sound when under load, such as during turns or when driving over bumps. This noise becomes more noticeable when the suspension moves, particularly on uneven roads. And common signs include a loose or unstable feeling in the vehicle, as well as vague or unresponsive steering, especially when turning, since ball joints are crucial for the movement of the steering knuckle. Okay. So what would be one way you guys can go road test and verify if it's a ball joint? Go find the most, for lack of a better term, right? The most fucked up road you can find and go drive through it. Or find some railroad tracks. Hit the railroad tracks real quick. Hit the railroad tracks and you just hear clack, 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 clack. All right, cool. More than likely I got a ball joint issue, right? Then, being that we're in the great state of California, what do you guys need to do before you condemn that ball joint? Got to measure it, right, with a dial indicator. Go whatever, find the manufacturer spec, set up your dial indicator, check it. If it's within spec, you're good. If it's not, you got to replace it. Okay. Next one. Oh, sorry. This is the diag. So when vehicle elevated test for looseness on the ball joint by attempting to push and pull the wheel inward and outward using ensuring that the steering remains stationary. In California, we have California Code of Regulations, CCR Title 16, Division 33, Chapter 1, Article 8, Section 3360.2. That's the whole process we got to go through in California before you guys can condemn a ball joint, right? Visual inspection, examine the ball joint carefully for any visible cracks, deterioration, or other signs of damage. Auditory check, listen for any knocking, popping sound that may occur while turning the steering wheel or driving over uneven surfaces. Okay. What if it's a sway bar? Sway bar leaks, what do? They help the vehicle during a roll, right? Or to corner. If it becomes worn or damaged, they may produce a clunking sound as the suspension moves, particularly when making turns or going over bumps. Unusual noises while turning, especially at lower speeds or rough terrain. You want to examine the sway bar links for any visible signs of looseness or broken parts. Inspect the rubber bushings or the ball joints on the sway bar links for deterioration, such as cracks or excessive wear. Most of the time, you're going to see them just oozing grease out of them, and then it's like, hey, this thing's got to go, right? Or sometimes you'll get a customer that says, you know what, as I like going into my driveway, I hear like a clack, clack, clack. Then go ahead and rack it, grab that sway bar link and give it a little wiggle. You'll feel it pop, and then that's when you know it's got to go. Those get sold in pairs, right? What if it's a bushing? What are you going to get? Squeaks? What if it's like completely gone? Clunking noise, right? A lot of times what we've seen, especially when it's like a control arm bushing, the car will feel like it wants to keep going when it comes to a stop, right? So you could pull it into the shop and just do like a quick emergency stop, hit the brakes, and you're going to feel that the car wants to keep going, right? Your brakes stop, but it stopped the suspension. The force that's still on the car is pushing the vehicle forward, but the suspension didn't move, right? It stayed still. The physical car chassis moved, right? So that's indicating to you got what? You got some bushings somewhere that are messed up or gone, right? Get it in the air and then figure out which one it is, right? Hopefully it's not a Toyota Sienna. Any guys ever done lower control arms on the Toyota Sienna? You got to drop the engine. 2009. It's like 24 hours to change control arms. Yeah, it drove the whole front subframe. Gangster, huh? All right, so conduct a thorough visual inspection. Obviously, we're going to be looking for any signs of cracks, tears, or wear in the bushings. Use a pry bar. This is going to be a good way for you to do that. This way you can move the control arm and see if you can get that noise to reappear. Again, for stuff like this is when we use the chassis ears. It makes our job easier, right? One of the worst parts about automotive repair and diagnostics is when you don't have the right tools. right? If you're trying to diagnose a noise, but all you have is a lift in your ears, it's going to take a while for you to figure that out, right? But if you have the tooling like chassis ears, you can move them to separate points. The loudest point you hear it, that's the component you're going to be replacing, right? It helps you quickly identify where you're headed with whatever you got to fix. Yeah. They're in the shop. I'll go get them. I'll get them after we're done. So we have a strut mount. Where's the strut mount at? The top, right? The bearing that's at the top of the actual strut. If that thing goes, what kind of problems are you going to have? Can we have a creak, clunking, or grinding sound? It's a bearing, right? So again, this is why I was mentioning earlier, and whenever you replace a strut, it's always recommended to do a loaded strut. Loaded strut is a strut shock absorber. It has the isolator bushing at the bottom. Then it's going to have what? Your spring and a new what? Strut mount, right? Again, you're preventing that car from coming back, and you're doing the job right the first time, okay? More noticeable vibration in the steering wheel throughout the actual cabin, especially when driving over high speeds. And a lot of times, too, it might give you a misalignment problem, right? Because that's the top of the strut. If that's off, is that going to affect the actual alignment on that particular wheel? 100%, okay? So, how do we check it? Easiest way is raise the vehicle and then start moving it side to side. The actual wheel, or the strut, it makes it a lot easier for you to be able to see if it has excessive movement or it's too freaking loose, right? Another one would be worn or leaking shock absorbers. Best thing is take a look at it, right? If you see any leaks around that shock or strut, recommend replacing it, right? Sometimes you might get a clunking, rattling, or banging. Sometimes when they're really bad, they'll rattle because you could grab it and just move it because it's completely gone, right? Okay, we can do a bounce test on it by pressing down on the vehicle and observing the movement. Excessive bouncing suggests worn out shocks or struts. Most of the time, you're going to spot it with them leaking. Right? If you see them leaking, go ahead and recommend them so that way the client knows whether they want to do it or not. It's up to them. Okay, if we got any dried out bushings, again, you want to let the customer know about that. Get that fixed ASAP because that's going to become a problem as they keep driving with dried or dry rotted suspension components. If we have a air suspension, air pressure issues with gas pressurized shocks, notice hissing sound when the vehicle is driving or suspension is compressed, right? Obviously, if you bounce it and you hear pss, pss, pss coming out, then you got a air shock that's leaking and you got to get it replaced. And sometimes you got to calibrate those too if you guys replace them. So speaking about that, if you guys replace a component, what is one good rule of thumb you should be doing before you replace it? So if you guys are aware, in service information, you guys can look it up. And during the procedure, at the bottom of the procedure, there's going to be a small little box that tells you what to expect after, right? So if you're going to do a job on something you've never done before, the best thing is to go find the whole process and read what service information is telling you is going to happen at the end, right? Because some of these shocks, especially if they're air struts or stuff like that, you got to calibrate them. You guys ever done a Range Rover calibration on air struts? Okay, you got to calibrate them. So if you're not aware of that, you put the strut on and the customer leaves and then call you a day later that the car looks sad and they send you a picture and the car's like bottomed out. That's because the air strut wasn't properly calibrated, so the whole system shut down. Okay, so if you didn't know that and you just put it in and you ship it that way, it'll work while it's at the shop. But once the car sits overnight, they're going to call you and tell you, dude, my car's on the ground. And I remember this because Range Rovers used to do this shit a lot. So then you had to go out there with your yardsticks and measure them, measure each corner, input it into the module, and program it. And then you would just see the truck just like come up and look like somebody was turning on hydraulics. It'd just be like bam, 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 bam. And like 5 minutes of doing that, then it would level itself out. Okay, so again, make sure you guys are aware of that. Now, before we do an alignment, what should you guys be doing visually to the car? Inspect it. What are you going to inspect? Do a visual inspection, right? What happens if you got a car that the customer is complaining about it pulling to the right, and you do a visual inspection and everything's perfectly fine and it's not out of alignment? Could it be a steering wheel? Possibly. What's wrong with the tires?
Different tires.
What was it? Yep, we had that happen today. We did a steering rack on a Subaru. Car left, came back today. Customer's complaint was it's pulling to the right. So we checked everything, and front tire was low by 13 psi compared to everybody else. We aired the tire back up, took it around the same road test with the client. Car was no longer pulling. Okay, so you want to be, before you go and say this shit needs an alignment, what do you want to check? Your basics, right? Okay. I ordered, I don't know if I mentioned to you guys, I ordered the tool. It's called the Tread Master. Well, yeah, we talked about it in class. So I get them tomorrow. Monday, we're going to play with them. So that way you guys can see them in action. They're pretty gangster. You put it in the center of the actual tire tread. It's going to measure tread and then give you an analytics of wear patterns on the tire. So it's pretty gangster for a little handheld tool. Yeah, don't hang out with me. You're going to end up buying all kinds of crazy shit. Camber. What is camber? Is that tilt of the tire? Or is that forward, back movement of the tire? Or in and out? I think you're just hungry, bro. Camber is going to be what? Tilt. Okay. If we got positive camber, is that out or in? Out. Okay. And if it's negative camber, in. Here's a good way to remember it. In, I-N, negative, N, right? So those two N's go together. When it's negative camber, it's going into the car. Is that true? Okay. And if it's positive camber, it's going away from the car. Now, if you have a situation where you got a vehicle that has one tire, let's say the right side has negative camber and the left side has positive camber, is the car going to pull? Which way? So the right has negative, left has positive. Which way is it going? Left. Why is it going to go left? Left has more contact surface of the tire, right? Remember, camber is always going to pull to the most positive side. Okay? That's key because you guys might see that on the test, right? Possibly. Okay, so camber generally causes the vehicle to pull towards the side with the most positive camber. It's influenced by the vehicle's ride height. Zero camber, meaning no tilt, ensures maximum tire contact with the road and promotes long tire life. Okay? What about caster? What is caster? Is that going to be like tire tilt forward or back? Okay. Where do we want it? Do we want it at 0 or just slightly positive?
Slightly positive.
Slightly positive, right? Here's a way to remember it. Positive, P, passenger compartment, P, right? So positive side is closer to what? Passenger compartment. Negative is away from it, right? Okay. If I go too negative, can that cause a pull? Yes. So if you got a problem where the car is pulling, it could also be too negative of a caster adjustment, right?
Caster negative towards front of the vehicle.
Caster negative is away from the passenger compartment, right? So towards the front bumper.
So
Positive
only,
is towards you.
caster only moves like forward.
Forward and back. Yep.
Okay. And negative means it's going
Negative means it's towards the bumper, yeah. Okay. Now, what's one of the objectives that caster does? What does caster do for us? Doesn't it help us center the vehicle after a steer? Right? So if I let go of the steering wheel based off of my caster, it's going to help me return back to center, right? Or straight ahead. Okay. So backward tilt from the vertical referred to as positive, while forward tilt is known as negative caster. Just like we could see right here, right? Okay, so positive caster goes towards the passenger compartment. Negative caster goes away from it, towards the front bumper, right? What's one key thing that we want to remember here? And it's this. Cars will pull where? To the most negative caster, okay? CC, that's where it becomes a little like, what? Okay? So the majority of vehicles use positive caster since it helps tires stay aligned in a straight path with little steering input from the driver. As most amount of positive caster increases, turning the steering wheel requires greater effort, and variation of caster can result in vehicle pulling toward the side with the most negative caster. Okay? What about toe? Remember the pigeon toe joke that you guys said, right? Okay. If we have no toe, we're going straight, right? We got toe in, literally is going in, right? Both tires are facing each other. And toe out is which way? Away from each other. Okay. So toe refers to the angle of the tires in relation to others when viewed from above. When the front edges of the tires are positioned closer together than the rear edges, that is known as toe in. When the front edges of the wheels are spaced farther apart than the rear edges, that is referred to as toe out, right? Incorrect toe alignment leads to tire wear. Is that true? Why? You're dragging it, okay? Because that tire, if it's towed in, you're going to be dragging that tire across the pavement, right? Toe can be measured in inches, millimeters, and degrees. Most machines now are in degrees, okay? Here's a key one that you guys want to remember. Most front-wheel drive vehicles are set with a slight toe in at rest. Okay, so let's process that. Which way are the tires? When the front-wheel drive, toe in, so the tires are inward, right? Why is that? When we torque it or when you go, what's going to happen to that excess weight? We're going to open them. So then it's going to go toe out and straighten out as you go. Okay, so front-wheel drive vehicles are set slight toe in at rest because the torque leads or loads affects the suspension during acceleration. Okay?
So if they were zero, they would be too much.
Yeah. So if they're zero, when you go, they're going to go toe out.
Not positive, right? Not positive.
No, so gotta see.
So out.
So it's gonna go. So then you're gonna start wearing them from the inside, right? And then when you have a toe in, you're gonna be outside. Okay. Would you guys agree that when we're doing a turn, our toe, let's say we're making a left-hand turn, right? Which wheel has to have more toe to it? The left wheel or the right wheel? The left wheel, if we're making a left-hand turn, right? The one that's closest to the turn has to have the higher angle, right? If not, it's not going to turn properly. Okay, the outer one has to have a less turn angle than your inner one. Okay, so that's why it's toe out on turns. You guys remember steering axis inclination? What is that? Remember, we formed this between the measurement of halfway through the actual tire, then the line that goes through the upper and lower ball joint, right? And then we take that measurement there. That's going to be our what? Our steering axis inclination, SAI. More to mark them, yeah.
Yeah, like to make those.
Or your machine will do it. No, this is just for your own know-how. No. But you just throw it away. I was like, I don't need that. I was wondering why you were writing so small. You're trying to sneak that into the test center, or what?
Write it on my hand.
Write it on your hand and then wipe off your sweat, and it's all your forehead's all blue. What do you guys know about thrust angle? What if your rear differential is out of whack? Your thrust angle is going to be off, right? You're crabbing it. What if the car was rear-ended, right? Pulled, but wasn't pulled properly. So now you got one side that's off by a couple inches than the other side. Is that going to throw off your thrust angle? All right. So if you guys get any questions on thrust angle, it's going to be associated to who? The rear axle. Okay. What do you guys know about tire wear? If the tire's underinflated, where is it going to wear from? Both outer and inner of the actual tire, right? If it's overinflated, where does it wear from?
Center.
The center. Okay. Now, if you have camber wear, if the vehicle is cambered out, it's going to wear from one side, right? If we're looking at that image that we have right here on the PowerPoint, this vehicle is cambered. Let's say this is on the right passenger side front tire. How's this vehicle cambered? Negative or positive? Negative, right? How can we say that so positively? It's on the inside. If it was positive camber, it'd be on who? Outside. Okay. When the tire is cupped, what does that usually mean? That means it's either a worn out suspension component, such as a shock, strut, bushing, or improper wheel balancing. Okay. And what's feathered? Toe. So if you run your hand from one side of the tire to the other, right? Okay, and you feel bumps like boom, 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 or feathering, then you know it's a toe problem, right? But then if you grab your hand and you go around the radius of the tire, okay, then at that point, that's usually when we say we got a suspension problem, such as a strut or something of that sort, right? Okay, because you're going to get a couple questions on that as well. Okay, so we're good on that. Feathered, cupping, and then overinflated, underinflated, and camber issues.
Maybe just better pictures of the cup and feathers so we can see the difference. Or they won't really use pictures.
No, they don't use pictures, if I remember correctly. No, they're just going to describe it. All right. You guys remember these from the other day? Okay, let's go over these real quick. So on this one, what's wrong with this car? It's all fucked up, right? This is a Honda CR-V. Must be a girl that drives it. Okay, she hit a bump somewhere going to Starbucks. Okay. So we got camber is at 1.4 degrees on the left, and then on the right, we got negative 1.4. We got a toe of 0.32 on the left and toe of 0.20 on the right. So on this one, what's going on with it? Not caster, camber, right? Which way is it going to pull? To left, right? Why is it going to pull to the left? Because our left camber has 1.4 positive and our right has 1.4 negative. Is that true? Okay. Which one are you going to calibrate first? And if it doesn't need a caster, and then if after camber, toe. Okay. So caster, camber, toe. So you guys would do the camber adjustment, get that centered, and then after that, you would go to the toe adjustment, right? More than likely, this one would probably be telling you that you feel pulled to the left-hand side. And then would you guys agree these tires are going to show some sort of feathering? Why is it going to be feathered? Toes off, okay? And we might have some wear. On this one, on the left-hand side, where's the wear going to be? On the inside, right? And then on this one, where's it going to be? On the outside, okay? On this one, this is like, I saw this when I recertified my A4 a week ago. I saw one similar to this. Not the numbers, but this is the setup of it, right? What's wrong with this one? You got positive camber on the left, negative camber on the right, okay? And then on the rear, we also have a negative camber on the rear and then more negative camber on the rear right. So would you guys agree this vehicle was going to be pulling to the left, right? even though the rear camber is still negative on the left, it's less negative than it is on the right. So what's going to be the pull tendency to who? To the left, because of the most positive, right? Okay, so on this one, we would put it up, then we would then adjust the actual camber on it, and then retest it and see where we were at. Is that true? What if you do the adjustment on the camber, but you can't get it in the green? What could be wrong with it? Could it be a strut? Spring? Right? Or a strut mount? Okay.
This would have
Button.
tire wear on the outer side on the left.
So left is 1.3. Would we have outer or inner wear? And then on the right? Cool. Right. What about this one? it's a little off, right? So we got again 1.4 positive camber on the left, negative 1.4 on the right. Our caster is okay, and then we got a 0.33 toe on the left and a 0.25 on the right. So is this vehicle going to pull? Which way? To the left. Look at your rear camber adjustment, negative 0.1, and then a negative 2.8. So again, it's going to be pulling to the left. Okay.
We got a positive on the left on the front and a positive on the right on the rear.
Then it's going to be turning. It's going to be like this.
That's a trick question.
That's a trick question. Yeah. The one you're going to see on ASE looks like that. Like this one.
What is that? Oh, as far as pulling to the left?
Yeah. So if you guys get the one I got, we'll just keep this between us. It said positive negative 20 on the left and like positive 40 on the right. So which way is the car gonna go? The right. That car's fucked up. But that's what I saw on the test. Okay, and it looked just like that. Right?
What's cross camber?
I think it's the difference between the two sides.
No, that's
It's not on the test. You can throw that one away too. All right. This one, what's wrong with this one? Is it going to go to the left? Yep. So we got negative 1.05 and then we got negative 2.3. So this one's going to have a left-hand tendency, so it's going to be pulling to the left, right? So then we would want to adjust it. This one also has negative toe on the right side, as well as camber issues. So what's going to be going on with this tire? Is it going to have wear and feathering? Okay, the tire's going to be messed up. Yes. So this one's going to have slight, but it's still in the green, so it's still kind of in the acceptable range. Yeah. Some long tires? Yeah. Put some, what are those called? Yeah, Lionheart. Some used ones. What about this one? Why is this one going to pull to the right? So we got a positive caster here, right? And then this one has a negative caster. What do we say about negative caster? That's going to pull to the most negative, isn't it? Okay. In the middle would be our what? Our camber. Right here, this camber is positive. This one's negative. So these two right here are going to pretty much work together to pull the car to what side? The right.
It's not enough camber to corner. It's on the right side for the positive. But yeah.
Does that make sense, guys? Okay.
The toe.
And toes off too on the left. Okay.
After like maybe since the cars are older, it's hard to put them in the green for some.
If it has worn out components, yeah, it's gonna be harder. So again, this goes back to servicing, right? If you guys are service techs, um, this is one thing for us at the shop. Some people complain about that you do a vehicle inspection, but it's not for you to sell them something, right? We do a visual inspection on any car that comes in the shop as long as it hasn't been here within 30 days, right? If it's over 30 days, you're getting another vehicle inspection. Why? Because this way I'm making you aware of what's breaking down on your car, right? So then later on, when I hit you with like, hey, we need to do like $3,000 worth of suspension work, you're not gonna be fucking pissed off at me because like, dude, I've been coming in here for 2 years and you never told me about none of this stuff, right? That's one way of looking at it. The other way is if something does happen, you already documented that it needed that work, right? Say you told the customers like, hey man, you got a ball joint that's going out, you need to get it replaced. No, just leave it. I'll do that later, right? You see the car on the tow truck a couple months later with the tire just popped out. It's like, oh, the ball joint finally failed, right? And then they show up to you and they're like, yeah, man, I don't know what you guys did to my car. It's like, we had a conversation about this. I showed you pictures. You said not right now. Okay, so it's not my fault. Does that make sense? So that's the two reasons why we do vehicle inspections when the vehicle comes into the shop. Okay.
Like a lot of the alignment people are kind of lazy about it.
Yeah.
I feel like they don't leave them right.
No, they want to do it quick.
Yeah, they don't really actually try to.
Well, one of the biggest things in our industry is which we're split in the middle. Some techs and shops do flag hours, and then some do hourly. Right? In my personal opinion, hourly is the best way because I'm not pushing you to cut corners. Right? When somebody does a flag rate, so let's say you're at a shop that does flag hours, right? They're going to tell you, I'm going to pay you 0.4 to do an alignment. If it takes you an hour to do it, you're still only getting paid on 20 minutes of your time, or 25 minutes of your time. Okay. Dealerships. Most dealerships are like that. When you go in for a diagnostic, they get paid 4/10 of an hour to diagnose a car. So if they can't figure out what part to put in your car within 25 minutes, your car is going to get pulled out and parked because they're not getting paid anymore to work on it.
Or just throw a random part at it.
Or just throw a random part at it. Clear the light and send it. If it comes back, I'll get another 0.4 to check it. Okay, that's how it works, right? And most alignment shops that you're talking about, that's how they get paid.
I see the numbers on there. I'm like, bro, those things don't even look like
Right? They're all
how
off.
they should look.
Yeah.
Like, you still pay them.
Yeah, and like for us, I mean, as a shop owner, most shop owners benefit from flag hours because if there's no work, you're not getting paid. Right? But in California, we have hybrid, so you get paid minimum wage, and then when you're working, then you get paid a different rate. But for us, we do hourly, so you get paid a full salary whether we have no work or there's work. You're getting paid the full salary. Then we do a commission, so you get salary plus commission based off of your productivity or what you get out during the week, right? So that helps us prevent cutting corners, and it keeps my guys focused more on doing a good repair and successful repair than getting it done fast so they could get out to make another job. Right?
Back then, they used to actually test drive them once they took them out fucking alignment machines.
Yeah.
And then now, or maybe the shop's taking it to that.
Yeah.
Care and he doesn't even test drive it after.
Well, there's a lot behind it. I don't know if you guys do this, but like for us, car gets dropped off. If it's like a drivability problem, we go on a road test with the customer. And then once the car comes back, then we go on another road test. And then we do a lot of that. And we record everything so that way we're on it. All right. So you guys want to do some practice questions? I got these from ASE. I didn't make these up. You guys ready? All right. Ricky, take out your notes. All right. While traveling at highway speed, a vibration is felt in the steering wheel, and the front end of the vehicle vibrates up and down. What could be the cause? Leaking power steering rack, static out of balance front tires, a binding ball joint, or incorrect thrust angle. B? A? D? E. Okay, why is it? It's your tires. I'm doing this, right? High speed. Okay. If you had a leaking power steering rack, is that going to affect with vibration? It's going to be steering, right? Okay. If you had a ball joint problem, what do you get with a bad ball joint? Clunking, right? And then if it was a thrust angle, will the car be driving sideways? Okay. So your best answer here would have been what? Tires. Okay. Here's the one trick that I want to tell you guys about ASE. When you guys are reading the questions, you go with the most correct answer. Okay. Doesn't mean it has to be 100% fucking bulletproof. It's the most correct answer. Okay. Because isn't there a dark blue that looks almost black? And sometimes you can mistake it for black, right? But unless you're asking me, is it dark blue or black, then I can't really make that differentiation, right? Yeah, right? Okay. So is it a chick or not a chick, right? All right. Next one. The front end of a vehicle dives excessively while braking. Which of these could be the cause? Who? B? D? A? What are your stabilizer bar bushings for? Turns, right? Okay. Power steering rack bushings. It's old power steering rack, right? Steering arm. Is that going to affect diving? No. Where's all the momentum going when you're braking? Springs, shocks, right? What's your best answer? Weak springs. Okay.
I was thinking about the question that you said about the old Ford.
Ah, yeah. The strut rod. You're going to see something like that. A vehicle with alignment readings shown has wear on the inside edge of the of the right front tire tread and pulls to the left. Is it front caster, front camber, front toe, or rear toe?
Camber. Camber.
I don't know. You guys tell me.
Inside. Camber front. Yeah.
Why is it the front one?
Pulls and tire. Negative 70. The rear.
All right. A vehicle with a rack and pinion steering has a shimmy. Technician A says that the worn rack to frame mounting bushings could be the cause. Technician B says that a binding steering shaft U-joint could be the cause. Okay, the way you answer these is technician A, true or false. Technician B, true or false, and then add them up. Okay, so what's your guys' answer? Who's getting fired? All three of them? Where's the third one?
test.
Fire the service advisor too. Fuck it. Clean shop. Start from scratch. If the steering shaft is binding, is that going to give you a shimmy? What's a shimmy? Boom, 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 boom. You want to dance? Boom?
Shoot, I thought it was
Oh.
shoot.
Got to get off TikTok,
Bro,
Ricky.
how old are these guys making this test?
We're in our 30s. During a wheel alignment, a technician finds the toe out on turns or the turning radius to be incorrect. The cause could be a bent pitman arm, tie rod, idler arm, or steering arm. Did we talk about a steering arm? Did we? Check your notes. We'll check your
I
notes.
didn't write it down, so I must have not typed it.
Take a picture and put it in Chat GPT real
I
quick.
think I will be. I'll put my money on B. 50 on. Oh, going to rates. Hitman on.
Another Tech A, Tech B. Vehicle pulls to the right during braking. Technician B says that a worn control arm or strut rod bushing could be the cause. Technician B says that a bent right wheel could be the cause. Who is correct? Both? Ugh. If it's a bent wheel, right, wouldn't you feel vibration and other stuff associated with it, not just during braking? This concern is only happening when? During braking, right? So if I have a bushing that's on a control arm or strut rod that's bad, isn't that going to cause that part of the suspension to move? Yeah. So when you're moving energy through that suspension stopped, but those bushings can't transfer the energy through it, what's going to happen to the suspension? Right? The vehicle is going to feel like it's moving. Okay. So that's why it's A.
We got one with third braking only.
Right. Keywords, guys. We got to look at the keywords when we're looking at this stuff. Okay. Here's the next one. You guys' favorite. A vehicle with circuit shown has a stored electronic power steering motor circuit voltage below threshold DTC. Man, if you guys get this wrong, I'm going to sock you. Data bus connector at W is open. Where's that? Right here. Is that possible? Where's the motor? Data bus wire shorted together at X. That would be right here. So that those two would be down. Is that possible? There's a high resistance in connector Y, which would be right here. Is that possible? And there's an open circuit at Z, which is right here. What's the code say? Below. Wouldn't that equal grounded of some sort? So could that be two buses shorting together or shorting to ground? Which one of these give you a short to ground?
B.
Can it be B? Okay, so right here, right? What are we talking about? Power steering motor. So the motor is going to be using up quite a bit of current, isn't it? So we have a 70 amp circuit right here. Would you guys agree that's more than likely going to be the one operating the motor? If I have an open circuit at Y, is that going to affect the amount of voltage measured by this module? So if the module has an open at Y, isn't it true that this module is going to detect a low voltage circuit? So then is it going to set a low voltage code? Yeah. You guys were overthinking it.
If it was X, it would have like
Okay. A pressure test is being performed on a vehicle with power steering. The pressure reading taken on when the wheels are right and left stop are below spec. The readings are normal when the tester shutoff valve is closed. What could be the cause? Ow. Getting old. So pressure readings taken at the wheels are at the right and left stop are below spec. The readings are normal when the tester valve is shutoff valve is closed. What could be the cause? On this one would be a failed steering gear. For number 9, this, by the way, what suspension type is this? SLA, short long arm suspension, right? So number 9, ball joint wear is being checked on the suspension shown. Technician A says that the jack should be placed at position X to perform the test. Technician B says jack should be placed at Y to perform the test. Where are we going to put the jack on this one so we can hold this suspension to test it? I think I put that one wrong. It should be X.
put it on Y, you would put pressure on it.
Mm-hmm. My bad. Told you guys I need to stop doing stuff quickly. And the last one, when you guys are taking your ASE, you need to be very careful with this. When it says this question contains the word except, read the question carefully before choosing your answer. If not within manufacturer specifications, any of these could cause tire wear except caster, wheel balance, toe, or camber. Right? Caster won't affect tire wear. Wheel balance, toe, and camber will. Right? Okay. Gangster. All right. How you guys feel?
We need to study.
Yes.